Hello everyone, welcome to In 5 Minutes. In this video we are going to see the next problem on type 2a. So this is our question, solve this and the limits are not given here, so we have to find the limits, and we are given the region which is given by x greater than equal to 0, y greater than equal to 0 and x plus y is less than 1. So first we will find what is x equal to 0. X equal to 0 is this line, that is y-axis. So this is our x equal to 0. So x greater than equal to 0, which means that this region, this entire region, x is greater than or equal to 0. Here x is less than 0, here x is greater than 0, and this is x equal to 0. So we have to consider this region, that is on right hand side. Then we have y greater than equal to 0. First, what is y equal to 0? Y equal to 0 is nothing but x-axis. So y greater than equal to 0, so it should be greater than 0. So this region is y greater than 0 and this below region is y less than 0. So we have to consider this region. Then we have x plus y less than equal to 1. First we will consider what is x plus y equal to 1. To find, this is a straight line. To find the coordinates of this line, we will put first x equal to 0. When we put x equal to 0, we get y equal to 1. So let's say y equal to 1 is this point. So this point is 0, 1. So this is y equal to 1 point. To find x coordinate, we put y equal to 0. We get x equal to 1. So x equal to 1 is, say, this point. So this point is 1, 0. So these 2 points are two ends of the line. If we join these 2 points, we will get a straight line, which is nothing but x plus y equal to 1. This part is x plus y greater than 1, then this part will be x plus y less than 1. So we have to consider the area x greater than equal to 0. So we have to consider x greater than equal to 0, y greater than equal to 0 and x plus y less than 1. So our area of interest is this triangle. Okay, so now we have to cover this area. To cover this area, we will first integrate with respect to y and we will then integrate with respect to x. You can integrate first with respect to x and then with respect to y. Since we are first integrating with respect to y, we will consider strip parallel to y-axis. So let's say this is our strip which is parallel to y-axis. So end of this strip is on x-axis, which is nothing but y equal to 0. And this point is on this line, that is x plus y equal to 1. So y will be 1 minus x. So we got the limits of y. Okay, so we got the limits of y equal to 0 and y equal to 1 minus x. We have to cover this region. Okay, so we have to cover this entire region and we are considering this strip. So we will move this strip from this point till this point. So we will move this strip from here to here so that our entire region is covered. So this strip is going from here. So here we have x equal to 0 and we are moving this strip from this point till this point. So here we have x equal to 1. We got the limits of y. Y is going from 0 to 1 minus x, which is representing this strip, and we are moving this strip in this region so that our entire region is covered. So our limits of x is x equal to 0 to x equal to 1 root of xy 1 minus x minus y dx dy. So this region is required only to find the limits of our integration, and now we will solve this integration. So we have root of xy 1 minus x minus y, so we can write it as x raised to half y raised to half 1 minus x minus y the whole raised to half dx dy. First we are integrating with respect to y, so x is constant, so x can be taken out here. So we get integration of x equal to 0, x equal to 1, x raised to half, and here we will get this term only, dx outside and dy. So we have integration of y equal to 0, y equal to 1 minus x. If you see here, we have this integration of y raised to half 1 minus x minus y raised to half. So this term is matching with some variable. So this term is nothing but y raised to half 1 minus x minus y the whole raised to half. X is constant, so 1 minus x is nothing but constant.